Evaluating polynomial functions. A paint manufacturer knows that the daily cost of producing X litres of paint is given by the formula C of X is equal to 0.001x squared plus 0.1x plus 5. A. State the degree of C of X. B. Find the daily cost of producing part 1, 100 litres of paint, part 2, 400 litres of paint. So we want to state the degree of C of X. So that means we need to write down the highest power. So we can see X squared is our highest power. So the degree of C of X is 2, i.e. the highest power. B, we want to find the daily cost of producing 100 litres of paint. So we're going to find C of 100. So we're going to replace each of those X's with brackets and put 100 into the brackets. So we just put that straight into the calculator and we get €25. So the daily cost of producing 100 litres of paint is €25. Next, we want to figure out the daily cost of producing 400 litres of paint. So this is done in the exact same way. So we replace each of those X's again with brackets, and this time we put 400 into the brackets, into the calculator, and we get €205. So the daily cost of producing 400 litres of paint is €205. An open box has dimensions x plus 3, x plus 1, and x, where x is the height in centimetres of the box. Find an expression for the external surface area of the box, S of x, and hence find S of 5. So if this is an open box, it means it has no lid. So that's important. So typically when we're trying to find the surface area of a cuboid, there are 6 sides to find, or 6 faces. So the top, the bottom, the front, the back, and the 2 sides. But this time we're only trying to find 5 of them because it's an open box. So there's no lid, so there's no top. So open box, no lid. So we're interested in the surface area. So it helps to draw out a picture. So here's our cuboid, and we know that the height is x. So then we're going to draw in our other dimensions. So we've got x plus 3 is going to be the length, and x plus 1 is going to be the width. So x plus 3 I've highlighted there in yellow, and x plus 1 I've highlighted in blue, and the height x I've highlighted in green. So the area of the side, so just focusing on the side here. So it's going to be length times width. That's the area of a rectangle formula. Length times width, so x multiplied by x plus 1 gives us x squared plus x. Then the area of the front. So again, it's a rectangle, so length times width, or in this case, you can say height, because we're using x. So it's going to be x times x plus 3, which gives us x squared plus 3x. And then we're going to do the area of the base. Now we can't see the base in this picture, but the actual area will be the exact same as the area of the top if there were a top. So the base has the same area as the top. So it's going to be x plus 1 times x plus 3. So again, length times width. And that gives us x squared plus 4x plus 3. So remember, this is an open box. So we've got 2 sides. So we've got this side that we can see here, and then the other side that you can't see. So we're going to multiply x squared plus x by 2. So that's going to give us 2x squared plus 2x. So that's going to give us the 2 sides. And then in the picture, we can only see the front, but there's also a back to the box. So to get the front and the back, it's going to be x squared plus 3x, again multiplied by 2. And that gives us 2x squared plus 6. We already have the area of the base. We don't need to multiply that by 2 because remember, it's an open box, so there is no lid, so there's no top. So we don't need to multiply x squared plus 4x plus 3 by 2. We just leave it as it is. So then we add it all up. So we've got 2x squared plus 2x plus 2x squared plus 6x plus x squared plus 4x plus 3. So this will give us the total surface area of the 5 sides, or the 5 faces. And that simplifies to 5x squared plus 12x plus 3. And we must have our unit of measurement, which is centimetres squared for area. So they told us in the question we were dealing with centimetres, but you need to make sure that you put in the squared part for area. The last part of the question says, hence find S of 5. So hence means using what you've already worked out. So we already worked out that the total surface area was 5x squared plus 12x plus 3 centimeters squared. So to work out S of 5, we're going to replace each of those x's with brackets, and we're going to put 5 into the brackets. And we get 188 centimeters squared. So just to summarize, S of x is equal to 5x squared plus 12x plus 3 centimeters squared, and S of 5 is equal to 188 centimeters squared. Given the function f of x equals 2x minus 4 for all x values elements of the real number set, find a, f of 3, f of minus 2, and f of t, and then b, for what values of t is f of t equal to t. So part A, we want to figure out f of 3 first of all. So we replace that x with a set of brackets, and we put 3 into the brackets. And then 2 times 3 minus 4 gives us 2. In the same way, f of minus 2, we replace that x with a set of brackets, and we put minus 2 into the brackets, and 2 times minus 2 minus 4 is 8. So f of minus 2 is minus 8. And then f of t, we just replace the x. You can replace with brackets, but ultimately when you multiply with the brackets, 2 times t will just give you 2t. So you get 2t minus 4. So f of t is equal to 2t minus 4. And then part B, so we're interested in the values of t where f of t is equal to t. So we let f of t equal to t. And then we replace f of t with 2t minus 4 because we worked that out in part A. So we have 2t minus 4 is equal to t, and then we just solve for t. So we get 2t minus t is equal to 4. So t is equal to 4.